Hi, everyone. My name is Arnansi Patnaik. I'm a cloud solution architect. That is my website. If you want to keep contact with me in this, I'm going to talk about Azure OpenAI Service. Okay. So within Azure, this is the overall AI portfolio. Uh, it's organized from SaaS to the most configurable. So right at the top, you have your SaaS applications like Microsoft 365 and Dynamics 365 and our partner solutions. These are SaaS applications that you just use. They are somewhat configurable, but they are not what you use to custom develop apps. So some of them would allow you to build plugins and stuff, but not full-fledged apps. Then you have this application platform, which are components that you can kind of plug and play, drag and drop to build stuff, right? So, and they all have AI infused in them. And again, there is a less customizable, like, you cannot like train a new model, but you can like use something and then add a UI to it, right? And then you have your customizable model, starting with bot service that you can use to custom build a chatbot. And you have these cognitive services that are pre-trained to do specific tasks, like cognitive search can index different documents and extract text out of it and index the text. Video indexer can extract text out of a video and describe the background. So you can use these, and they are all customizable, that you can kind of add your own data to it and create your own custom build, so your version of the model recognizes your data, right? And then you have your core cognitive services. These are like vision, speech, language. Vision APIs can recognize images, faces. Speech can transcribe speech to text. Language can translate between languages. And the Azure OpenAI service falls within this customizable AI model. So Azure OpenAI services are large language models, which are pre-trained with a vast amount of data that we'll see later, that they can be customized using your data. And right at the bottom, you have the Azure machine learning platform that you can use to custom code an AI model from scratch. You provide your own data, you write your own code. So it's the full level of customization is available with using Azure machine learning. Now, artificial intelligence, the idea started in 1956, was the idea to create a machine that acts like human, right? So machine learning is part of it, which is about, how to use the data to train a model to understand how to predict certain things, right? And then deep learning is an subsection within machine learning that is a specific type of modeling using a neural network. And then now generative AI is specific part of deep learning. So there is a specific type of deep learning model called sequence model. From there, the transformer models got created, and that formed the basis of what we know today as generative AI. In the generative AI, there is this concept of a foundation model. Like I said, we provide these models and they're customizable. So they start with a foundation model. Within the OpenAI or the generative AI models, you have these foundation models that are pre-trained on a vast amount of data, but they're very generic in how they behave, right? So they're already pre-trained on that data to kind of generate things in a generic way. And how you generate things and what they generate, there is an adaptation layer to it, where you layer it with a specific type of behavior. So whether it's a question answer type of interface, or you want to do specific sentiment analysis, you only want to do image generation, you only want to do code generation. So that adaptation part of it, you add on top of it to make it dedicated to a specific type of task. These large language models are not new to Microsoft. Even before OpenAI, right from when the BERT language model came out in 2018, it had 340 million parameters. Microsoft continued its research from there on large language model. The BERT was an NLP, what we call natural language processing model. Then the next evolution was the natural language generation model. That's where this generative AI concept got started. So Microsoft had this project called Project Turing, or AI at Scale, which used hardware infrastructure like DeepSpeed and Zero to create models like Turing NLG, Megatron NLG with NVIDIA, and TURLV. All these models were created, which are pre-OpenAI. Right? Using NVIDIA's processing power, in 2021, this Megatron model was created, which had 530 billion parameters. Next, OpenAI partnership happened around 2019, where OpenAI was a company that had the mission of ensuring artificial general intelligence benefits humanity, and Microsoft's mission statement is to empower every person and organization on the planet to achieve more. So, they had this common vision to do good with technology. So it was a good partnership. And with the partnership, OpenAI was able to use Microsoft's infrastructure to train their model, and Microsoft became the first public cloud to offer OpenAI as a public cloud service. With Azure OpenAI Service, you get these foundational models like the GPT 3.5, the GPT-4, and ChatGPT, and DALL-E 2 for image model. The GPT-3 models are slowly getting deprecated. So the main models that you see now being used are GPT-4 for language prompts, and DALL-E for image, and ChatGPT for conversational interface. Right. So the GPT-3 models had evolution starting with ADA model to Babbage. Like over time, they just kept increasing the number of tokens. So we'll talk about tokens later, but tokens are a measure of the size of input that they support. And then we had the Codex model, which my colleague talked about earlier. That's used in GitHub Copilot. We'll talk more about that later. There is a specific naming convention used with OpenAI. So they are there's a family like text, and then there is the capability. Da Vinci is the type of model, and then the version. Right. So that's kind of the naming convention of all the large language models. Okay. OpenAI Codex model was the model that was used to do code generation. This is what the original GitHub Copilot was based on. You saw a demo earlier for Copilot. So Copilot allows you to generate code using a natural language right from within your IDE. And then next, the GPT 3.5 was used to build the ChatGPT model, which is, by far the most popular model. And it was the NVIDIA CEO who said, ChatGPT is the iPhone of AI, because before a ChatGPT there were many models. Like ChatGPT itself is built on the GPT 3.5 Turbo, which is a model by itself, but people did not find it very practical to use. It was ChatGPT that introduced a human-like conversational interface, which made it appealing to average users. That's where the adoption skyrocketed. That's why ChatGPT is so popular, because of that seamless human-like way of interaction. Now, GPT-4 is slowly replacing all the earlier version of GPT models. Soon, GPT-4 will replace Codex as well. Already, the GitHub Copilot X is using GPT-4. Now, using the GPT-4, the top capabilities are content generation, like call centers are able to generate automatic replies to common questions. There are a summarization used on. You will see later how we have our own Copilot that can summarize meetings, code generation, of course, in GitHub, semantic search, where we can search beyond a particular text index and actually index the meaning of a word, not just the word itself. When to use OpenAI? Typical use case for OpenAI is that you need a general purpose model that can handle multiple tasks, right? Or you need a human-like interface. You need to rapidly prototype something to make it, go to market ready, because these models are so generic, and they're already pre-trained on such large amount of data that they really need very little customization to be able to do your particular task that you need to do, right? They require very little to no training. In fact, we'll see later that Azure OpenAI does not really require training, but we'll see how to customize it. And it's something you want to use in a use case that are the previous use case that I talked about, and it's something that you want to use to kind of explore a new solution that you don't necessarily want to build a custom model for it. One of the ways to customize the OpenAI model is prompt engineering. Right? With prompt engineering, you are kind of giving input to the chatbot, which is using an OpenAI model, right? And within the input that you are giving, the text that you are giving input to the chatbot, you can be descriptive. And the typical format is you give it one command, like classify this question from category 1 to 3, and then you give a detailed guideline that choose one if it's auto insurance, 2 if it's flood insurance, 3 if it's not relevant to insurance, right? It's similar to like how you get when you call a customer service and you get automated audio telling you instructions, right? So you want to kind of give that type of instruction to kind of guide the model to pick a particular type of category, right? And these inputs are called sorts. So when we say zero sort, that means you gave the command, you gave a detailed description of how to interpret the command and how to find the classification, but you didn't give any example. And the number of examples you give, that's the sort, right? So on the right, we see a few sort example where I'm giving the same command, giving the same instruction, but with that, I'm also giving 3 examples that, the first sentence is of example of topic 2, second is of 1, third is of 3, right? So I'm giving 3 examples. So this is when we say zero sort, one sort, few sort. Zero sort means no example provided. One sort means one example provided. Few sort means, more than one example is provided. One of the issue with large language model is hallucination. Sometimes you ask it to do something or ask it a question and it doesn't know the answer, but it starts making up answer, right? And there are, guidelines that you can implement to prevent the model from hallucinating. The first is you want to include a strict instruction that if you don't know, don't make stuff up, right? If you don't know, just say don't know. You want to restrict the output, like you want to give a detailed instruction with examples to say, in these scenarios, do this. In other cases, just say don't know, right? You want to add a chain of thought process. You want to kind of give it a flow chart of how to think and how to respond. You want to repeat some of the sentences or words that are important to you, because repetition is how the model understands what's important. You want to position the most important instruction by making use of latency effect, right? Uh, this is where you're kind of, saying that, these are my, just by the way, the last one is most important. So the last one kind of overrides everything else, right? So you want to position your instructions in a way that it's clear to the model that which one you care about most. I talked about tokens earlier. So tokens is a measure of how much input you're providing to the model, and different models have a capacity of how many tokens they can use. There is no direct math of how many characters is one token or how many words, but roughly you can say 4 character or 0.75 word is a token. That's a rough math. Don't take it literally, but there are tools more that will tell you when you provide input how many token it is, and if you look at the documentation of the model, it will tell you how many tokens it supports. Along with the token, there are other parameters like temperature, right? So a temperature is what determines how probabilistic a model is, right? A temperature of 0 makes the model deterministic, meaning it will always give you the same answer given the same question. Any temperature between 0 to 1 will add that probabilistic effect where you might get different answer at different time. So temperature is another parameter you want to control. Within Azure AI Studio, you'll see different parameter, and it gives you explanation of what those parameters mean, and those are things that you can control to get the right output. Right. Besides prompt engineering, another way to customize the model is fine tuning, right? So people ask me, how can I train a large language model using my data, right? Azure OpenAI Service does not allow you to train your model. You can take a foundational model and kind of train it. You can get just compute in Azure and just train your own model, kind of do similar to what OpenAI is doing, right? But that requires a lot of compute power. And Azure OpenAI service does not allow you to retrain the model for reasons like we'll talk about responsible AI later. But we want to make sure that the model that you are using is safe for enterprise use. And that's the reason why we do not allow people to retrain the model. We only allow people to customize it using either prompt engineering or fine tuning. Okay. In fine tuning, what you are doing is you are giving it a lot of data and saying, okay, you're trained on a lot of data, but now also learn this data, and this data is important to me. So when you are giving answer, give answer based on this data first, and then you can go back to your core data set, right? So it utilizes transfer learning. So whatever the model already learns, on top of that, it learns something new. And then when you do fine tune, it kind of, is similar to few sort learning, but it's all kind of gets embedded into the model. Okay, when you fine tune a model, models bias changes. So fine tuning a model actually produces a new model, but it's not a retrained model, it's a fine tuned model because it kind of contains all this extra information, right? So when do you want to use fine tuning? Typically, if some of the Less capable models sometimes are cheaper, and fine-tuning those models sometimes might give you a better result for lesser cost. So that's a common reason to use fine-tuning on lesser capable models, right? If latency is of utmost importance, that you want to give an input and get an output as fast as possible, then if you have trained the model on the data that you care about, that requires you to not give it a very detailed example, or provide it too many sorts in your few sort prompt engineering to ask a question, because it already has that data. If you're not providing it a lot of input in during the time you're asking the question to a fine-tuned model, then because it's processing less text, it takes less time for it to respond. So latency increases when you have fine-tuned the model and you are providing a less amount of text in your input. If you have high quality of data and you want to make sure that the model understands the data, that's where fine-tuning would be useful, because you want to make sure that your model is recognizing your data and understands that that's the ground truth, and respond based on that, right? Or you are trying to train a model on a domain specific. So you are on financial services, you want the model to understand what a loan is, what actuary does, things like that. Those domain specific terminology can be provided to the model through fine tuning. Typically, this is kind of the general process. Within Azure AI Studio, you can do the entire fine-tuning using a wizard, right? So typically what you do is you take your base model, and you take your data, in this case saying GPT-3, but it can be GPT-4 or any model, and you provide it the data and you say, okay, now do the fine-tuning. After you do the fine-tuning, it generates a new model with weights and bias adjusted, and that new model would have a new deployment. So it would have a new URL that you can use in your app. So now your app connects to this new model with the new deployment API that will give you responses based on your domain data. The advantage of using Azure OpenAI instead of OpenAI by itself or training your own model is that when you use Azure OpenAI Service, a lot of the enterprise grade features like authentication, authorization, making sure your data is secure, making sure only the people you authorize are able to access, all those features get included into Azure OpenAI service. On top of that, Azure also makes sure that when we get a model from OpenAI, it's already meeting some of the responsible AI guidelines of Microsoft, like fairness. It's to make sure that it's treating all users fairly, that it's explainable. You are able to explain to an auditor how the decisions are getting made if an AI is involved in the decision, right? Counterfactual, like for a particular data point and a particular feature, what is the correlation? How much of the prediction is changing for a particular data point and a particular feature? What are the causal analysis? What might happen to someone based on the usage of AI, right? How error prone is it? And if the error happens, what might be the repercussion, and what is your prevention mechanism for it? And using all this, it will generate a responsible AI scorecard, a PDF document which can be read by a technical, non-technical user, that can be used in case of an audit, right? Microsoft Cloud runs on trust. So this is the big differentiator for using the Azure OpenAI service. instead of direct OpenAI or using any open source type of large language model, is that Microsoft takes care of the data security and security of access to your AI model. Using the OpenAI model, Microsoft has already built a huge line of application which are branded as Copilot to kind of give an example of what can be built using these AI models on top of enhancing the existing products that Microsoft offers, starting with Microsoft M365 Copilot, which is your mostly the Office application, the Viva Sales, which is what I was talking about, that embeds into team and gives you a summary of what happened in the meeting and what are the tasks, right? Bing search engine and Dynamics CRM, right? So the first one is M365 Copilot. So M365 Copilot includes the large language model with your data, and it works across all the apps within M365
You can start
ecosystem.
by asking Copilot to summarize all your recent customer interactions, meetings, content you've shared, any issues, and deliverables. Copilot works across your calendar, emails, chats, documents, and meetings to find all the pertinent information. Now you've got a concise summary, complete with citations and sources. You can hover over names, quotes, and file names to verify information or find out more. Now you know product lead times are likely to come up, so you ask Copilot to help you prepare all the details.
Okay, so that's just an example of M365 Copilot working within Teams. Teams is part of M365, right? Besides Teams, there is also Word, Excel, PowerPoint, Outlook, right? So all of those have their own Copilot, and within Word it will help you summarize or edit and generate text. Copilot Excel can help you explore the data. PowerPoint can help you create a presentation. You give it a bunch of text, it will give you design suggestions. In Outlook it can help you clean up your inbox and help you focus on the most important email, and give you insight on what are the key takeaways, what are the actions you need to take, right? And Teams, we just saw the demo. Now the Power BI also has Copilot that helps you create reports. We just Viva Sales it also lives within Teams, and it helps you generate email content, auto logging. So the general flow of the entire sales process, it helps you automate a lot of tasks. I see there are some questions.
Hey, Arun.
Yeah.
How can you protect proprietary data that's used? And how do you go about, let's say, and we've had this happen before, maybe you could comment on this before we finish up. How can an organization use these powerful AI models, but how can you make sure that as you train them, you reap the benefits, and let's say a competitor won't take advantage of your training these models?
Yeah. So
you could comment on that.
Right. So that's the biggest advantage of using Azure OpenAI Service. First of all, you have to be technically correct. You cannot train the Azure OpenAI model. You can only fine tune. When you are fine tuning the model, your data lives within your Azure subscription, which is safeguarded through networking controls. On top of that, there is a data encryption. So on Azure, every data is stored at rest. All endpoints have private endpoints, which is only accessible from your network, so nobody else will have access. It's also protected by key and role-based access control. So there are all these access controls available to you to ensure that your data is your data after you train the model, it's deployed within your Azure environment. You get a URL. For that URL, you set the authentication, you decide who has access to it and who can do what with it. So with all that control, you can be assured that your competitors are not going to get access to it, and your data is not going to leak.